we are studying only on Tuesdays and Thursdays. What do you do? There's only one course every right? So what do you do after? What do you do Wednesday, Thursday, Friday, Saturday, Sunday? Oh, you have an exam this Thursday. This was we had plenty of time after Thursday. I didn't give any proper sense. Lots of time. We had a class on Wednesday last week. Or Wednesday or Thursday? Thursday. Friday, Saturday, Sunday, 3 days. This was on finance or financial? DSG. But, in which course? In the DSG course? Closed and open. That does sound good.
And I feel like we combine all the foundation knowledge into this course.
Into one. Now the DSG model is for basic model that is used in macro. I didn't see DSG. I didn't study DSG models as part of college. When I went to graduate school, there were no DSG models. We basically just had some simple, that was the time when we were talking about rational expectations, and now your rational expectations all the way. So at that time, people were still debating rational expectations, adaptive expectations. In the 1980s, that's when the whole debate started. The results that we were getting, the real business cycle models, the results that we were getting from people didn't like came there. That's when we started introducing frictions into the market, arguing that the real business cycle model is not a very good representation of the economy because you have business cycles and the economy going up and down is not all optimal. It's the frictions that can generate and in the real business cycle model there's no room for policy. Everything is optimal. Households are making optimal decisions with rational expectations. There's no goal for monetary policy. And because wages and prices are so quickly so important all the time. Everybody wants to as important. So there's no unemployment. When you start introducing friction, then you get unemployment, you get business cycles, and you have to go for monetary policy. Big deal. Okay, let me start. Okay, so here we have the output for the US on an annual basis. We ran a logarithmic regression, and the question I asked you was, do you like this regression? Do you not like this regression? One thing I noticed is that the Durbin-Watson statistics is very far away from true, which means that there is a lot of serial correlation in the data that has not been taken into account. So what it's telling us at the very least you should have a lagged output here. It should improve. I mean, this is already quite good, but there is serial correlation. Anyway, this is one very simple way of thinking about trend. Let's now apply the HP filter to the data. So we have the same data, and if you have no smoothing, okay, then all you get is a number. You not smooth anything, you just get one number, and that becomes your trend, but that's not exactly what we're looking for. If you smooth it a lot, okay, then you get a line that looks like this, and you see that there is a positive output gap for a long time, which is this part here. You have a negative output gap for a very large time, which is this, and then you have stuff going up and down. That also does not look very realistic, because we know that business cycles are much shorter. So this is a time period going from 1955 to almost 2000. You don't have a recession in the US economy for 45 years. That's not what a business cycle is. And you don't have a boom in the United States for 5 years and then a recession for all of this time. This still does not look like a business cycle. What if we, since we have annual data, if we use the smoothing parameter of 100, which is recommended by Hodrick and Prescott, right? First of all, notice that this curve is not, one thing I want to show you is that this very smooth curve almost looks like a deterministic trend. But where it starts and where it ends is quite different. So you would compare this to the deterministic trend, but they give very different results as to the business cycle in the US economy. When you use a smoothing parameter of 100, first of all, notice that this line is following US GDP more closely. Okay. And you see the output gap running through zero very, very often. So this does seem to look like a business cycle. Okay. You have periods of 2 to 3 years where the economy is below potential, then goes above potential, then it comes back. So this really does begin to look like a business cycle. And in particular, during the global financial crisis and during COVID, it shows you that the economy is definitely working below potential. So this does begin to look like a business cycle. So when we compare the output gap using the deterministic trend or a very, very high smoothing factor in the HP filter, we get an output gap that sort of looks like this, but this a long period of negative potential output gap, a very long period of positive potential output gap, and then again a very long period of negative potential output gap. That really does not quite look like a business cycle. And when we compare it to a smoothing of using a lambda of 100 in the HP filter, we see something that begins to sort of really look like. So even when you use the HP filter, it's all very simple and common, but you want to ask yourself, does this sort of look reasonable? Okay. So whenever you apply the filter on any time series, and as part of your presentation, what I would like you to do, and I'll explain to you by the end of the day what is expected in your presentations. What we are doing today in terms of assessing the condition in the economy, whether it's in potential output, I would like you to do for a country of your choice. Okay, so we are going to do all of this for Vietnam today, and I will show you the spreadsheets that I'm using to do it. You can use either those spreadsheets, or you can construct your own charts and tables, since you all know Stata and other econometric packages. The idea would be that you pick up an economy that you're interested in. Pick an economy which is an industrial economy, or pick an economy like Thailand or Malaysia, for which you have data that is available. And you want to take the GDP series to first estimate potential output. Ask the question for your country, when did the economy have booms and recessions? And once you estimate the booms and recessions period, what we will do next week is to ask the question, what did monetary and fiscal policy do? And whether fiscal policy and monetary policy were appropriate for the state of the economy. When the economy was in a recession, was fiscal policy helpful? Was it expansionary? When the economy was in a recession, was monetary policy helpful? Was it expansionary? Was it contractionary? So you want to pick a country of your choice, collect the data for that country, estimate its position on the business cycle, and ask the question whether economic policies were appropriate for the state of the economy. So that is going to be your assignment for your presentations. Okay? And for your presentations, I don't know if I've already said it, pick a partner. Okay? Pick one more partner. I think we have 8 people with us, 2, 4, 5, 7. Is one person missing? One person is not here today, right? And that person did not come last week also. Right? They did come last week. Okay. So we have 8 people in the class, 2, 3, 4, 5, 6, 7. I'm not included in the presentation. So find a partner, choose a country, and today we'll see the kind of data that we need to collect to do this kind of analysis. The first data that we need obviously is real GDP data. Right? So you need to collect real GDP data for your country, and it's best to do stabilization policy analysis on a quarterly basis. And I will show you the quarterly data for Vietnam. Whatever we have to do that analysis, for the country that you choose, the quarterly data might be more easily available. But I'll explain to you at the end of the day again what it is that I expect from your presentations. A second point that we tried to make was that a statistical method like the HB filter can misidentify boom and bust periods. In particular, the HB filter has an endpoint bias. The choice of the parameter, lambda. If I use lambda of 1500, I get a different answer. If I use a lambda of 10,000, I get a different answer. So the choice of the lambda affects my judgment about whether the economy is in a recession or in a boom. And you just have to make a judgment whether it looks okay or not, but there is no other way of double checking your judgment to say whether what I have is right or not right. So it basically looks about okay. A second problem with these statistical filters is that they do not identify structural changes. It's just a smoothing parameter that's going through the economy. Okay? If there are large changes in the economy, and the case of, or there are very large shifts in output, for example, as we had the global financial crisis, output shifted by a hawk, that was not potential output, it was just a very large exogenous shock. Okay? The global financial crisis also in some ways was a very large shock, maybe not entirely exogenous, but still it was a very large shock. So, and we don't know. For the case of the US, they tried many things, and they probably have some algorithm to say that for annual data you should use lambda 100, for quarterly data you should use 60, 100, but we don't know whether those numbers are good for Vietnam, Thailand, Malaysia. So one would have to do a full detailed analysis to come up with an optimal lambda for other countries. So to overcome some of these problems, we use a production function based approach. But again, in the production function approach, as we'll see, we have to end up using a filter for total factor productivity. This is the representation of the end point problem. If I use the entire data, right, then my business cycle looks like this. If I use a shorter time period, for most of the part, the business cycle looks okay, but notice that the output gap here, if I use a shorter sample until here, is very different from the output gap that comes from using the entire sample. So depending upon whether, so the data starts at the same point, but in the case of the blue line, I use the entire data set from 50 to 2023. In this case, I use the data maybe only up to 2008. The orange line is telling you that the recession associated with the global financial crisis in the US was much deeper, if I stop here, compared to using the whole data set where the output gap is much smaller. And it's also telling us that the boom in the blue case was much higher. Recession was not as deep. The orange line is telling us that the boom was not as large, but the fall was much bigger. So depending on what data are used, the filter is very sensitive to the endpoints that are being used. This is the quarterly GDP data for Vietnam, and this is a log of the quarterly data. Let's now look at Vietnam. This is the data for Vietnam from the World Economic Outlook, a long series, and this gives you the percentage change in Vietnam annual GDP growth. Once again, this is COVID. That seems to be the only time when the growth rate in Vietnam fell by a lot. And in the mid-1980s, there was a low growth rate. But by and large, Vietnam has had very high growth rates over this time period. Let's open the Excel file and see whether we can, so go to Moodle and find in the exercises a file which says aggregate supply analysis. And you should be in a file where the first page looks like this, and the tabs at the bottom are like this. Everybody has that file open?
Yep.
Also in Moodle, let's see if it works on your computer or not. But if it doesn't work, then you have to use either Stata, or I'll have to give you the HP filter. So notice that under assignments and exercises, there is a file which says HP Filter Excel. Download that file into the folder where you have downloaded the aggregate supply file. So in my case, for example, this is my file where I have the aggregate supply analysis. And in the same file, I have HP Filter XLA, which is a macro for Excel. Got it? Now you want to activate this macro in your file. And the way to do that is go to Excel and go to File, so go to the tab which says File. Actually, the best way to do is to read the instructions under HP, and this tells you how to install the filter. So try doing it if you can, and if you have a problem, I will come to you. It's already valid. How do you want to check? See, let me see how I check. You don't have something called developer. can ask ChatGPT. Yeah, try that. How to install a macro in Excel on an Apple computer. Okay. Does everybody have this macro installed? So, in your developer, if it got done right, correctly, and you look at Excel add-ins, you should have something which says HP filter. You have it? Very good. Good. What computer is this? This is Windows. John, you have it?
Where I can.
Your computer is a Windows computer or a Windows, right? Okay. Here, you have the HP filter. Okay, good. Apple computer. You have the filter?
Ngày hôm nay Tuấn không dọn. Cái là add cái file vô.
Okay, go ahead.
Hai bạn xài với nhau.
Emma, I got you an expert. First download. No, first you have still not downloaded the filter. So go to Moodle. Go back to Moodle. You have to download from Moodle first. No, you don't have it yet. Why don't you have it? Oh, you have it. Where did you download that? Now go to Tools. Very good. Well done. Okay. Okay. So here we are. We've downloaded the Excel. Excel. We've downloaded the file. We also have the HP filter. We're going to start using the Excel filter in Excel. Everybody's happy. So the first thing that we need to do is to get the data. If you're going to find out the output gap, what data do we need? Output.
Of course.
Okay. So this is the output data for Vietnam, which I got from the NSO, and you can again download this data from the NSO. Now, one little thing that happened was that the NSO revised the series in 2021. Okay? So there was an old series for GDP, nominal GDP, and there was an old series for real GDP. In 2021, the data was revised. First, they provided 1 year of data, so there is 1 year of overlap. Okay, so the old series finished in 2020, and first they gave a data for 20, so there was one overlap. Then they revised the data going back. Notice that the division was very large. Look at real GDP here in the old series and the GDP in the new series. When they did the revision, they said that Vietnam's real GDP was almost 30% higher than what they thought it was in the old series. So look at this number, for example, if you look at the number 2020, the real GDP in Vietnam, so you were 30% richer than you thought you were. That's a good feeling. Your per capita income was 30% higher than you thought it was. Now that we have 2 time series, now they revised the GDP series, but some of the other components of GDP were not revised. In particular, the annual series was revised, but the quarterly series was not revised. They did not provide a new quarterly series for real GDP data. So I have an old series, I have a new series, annual data, but I don't have quarterly data. So what I did as part of this exercise was to take the old series and the new series and use the ratio of the new series to the old series to adjust the quarterly data. This was the old quarterly data that I had. Okay. I can use the ratio of the new series to the old series to create a new adjusted series for quarterly data. It's not exact, right? Because the whole year's GDP has gone up, but I don't know in which quarter the GDP went up by more and which quarter it went up by, but I just use the ratio, okay? So you will notice that, so the NSO produced the annual series, so they produced new series for nominal and real GDP, but they did not produce a revalued series for nominal GDP. And after some time, they started producing the quarterly data also on the new basis. Right? So the annual data was provided on a new basis, quarterly data was produced on a new basis, but they never produced the old data, quarterly data on the new basis. So this is just a simple adjustment. You will notice that if you go down, the adjusted series is the same as the revalued series, because this is where they started producing new data. They produced new annual data and they produced new quarterly data. So for that time period, the two things should be the same. Because this is that 30% higher GDP, we're getting a new series. But everything before that, okay, has to be adjusted. You have the old series, you have to adjust the new series by the ratio of the new annual number compared to the, so if the new number, annual number is 30% higher, then the quarterly number should also be 30% higher. Right? It's a simple adjustment. There's no other way that I can think of doing the adjustment. One can get a little bit more sophisticated by applying seasonal factors, seasonality, because in annual data there is no issue of seasonality. But in quarterly data, there is an issue of seasonality. You will find that GDP in the first quarter in Vietnam will always be higher than in the other quarters in Vietnam. Why?
Seasonality.
Tet,
Consume.
right? Because of Tet, you will always get real GDP in the first quarter to be seasonally higher than in the other quarters. The other 3 quarters are roughly the same, but Tet is always generally going to be higher. So based on that, I did this adjustment, and you will also notice that I have data only up to 2023. If you're interested, you can obviously get data for 2024 from the NSO. So you will have this number, you will have this number, and if you go down, and in fact, I think you have data for 2024, but quarterly data is available up to the second quarter of 2025. So if you want to do some analysis of Vietnam, you have a quarterly series for about 15 years. 15 years, quarterly series means you have 60 data points. That's quite a few data points if you're trying to do some analysis on GDP for Vietnam. And then on the other side, I have some checks, but basically, I use the annual data to create a quarterly series of nominal GDP and real GDP for Vietnam for about 15 years. So let's take that data and as I mentioned to you, there is seasonality so we take the nominal GDP, which is coming from the previous sheet. Okay. We take the real GDP that is coming from, so these numbers are coming from the previous sheet. Okay. We know by definition the GDP deflator is what? The GDP deflator is just nominal GDP divided by real GDP. Since the base year for this series is 2010, the real GDP deflator annual is 100, and because I made this adjustment in such a way that the nominal GDP in each quarter is equal to the real GDP, that number is 100. I think I've done it correctly. And after that, obviously my GDP deflator number will change. I then take my quarterly real GDP, non-seasonally adjusted, and I said to you that Tet is always an issue, so I want to find out a seasonally adjusted series. Okay. Have you done any kind of seasonal adjustment in Stata? In your econometrics, did you do any seasonal adjustment? Did some seasonal. You have econometric packages that provide, in particular, I think one of the Bureau of Economic Plans produces an X11, X12. Have you heard about X11, X12, X13? These are packages that are used to seasonally adjust the high frequency data. Let's see what the difference is. Okay. First of all, notice that these two numbers are different. Okay. So the seasonally adjusted real GDP is different from non-seasonally adjusted. Different. So you have a different series here, and this seasonal look at this number. This series is much more smooth compared to this series because it's taking out the impact of seasonal factors. So in quarters in which real GDP is too high because of seasonal factors, because of factors like TET, because of Christmas, in those quarters it will shrink the GDP to take out the effect of TET or take out the effect of Christmas. And in the other quarters, it may either bump it up a little bit more or keep it the same. Okay? So it does that adjustment. The program has that capability. So you will see that this series is much more smooth compared to this series. Let's look at the chart. So look at the graph in the next sheet. And these charts, as soon as we keep filling the file. So this is the nominal GDP. You can see that there's a lot of seasonality because every 4 quarters, this number seems to bump up. Right? It goes down a lot, then bumps up. So there's a lot of seasonality. There's a pattern of seasonality. That pattern of seasonality seems to sort of go away here, but in this part of the series, there's a lot of seasonality. So when you seasonally adjust it, this series will become much more smooth. And I don't have a chart where I should be able to show you seasonally adjusted numbers, but you can. Well, let's create a chart. Let me see if we can do it. Okay, so take these two series, and let me see if I can quickly create a chart. This is my non-seasonally adjusted series. This is my seasonally adjusted series. The seasonal adjustment has taken out all of these large fluctuations across quarters and given me a seasonally adjusted series, which is much smoother because it's taking out the effect of TET, it's taking out the effect of quarters, and the differences between quarters because of special factors that happen every year in the same quarter. And the same idea of seasonal adjustment will be relevant when we start talking about inflation. Okay? And you can go at the end of the day to, do you have EVs? Does everybody have EVs? Do you have Stata?
Yes.
Take the series, the nominal, the real GDP series into Stata. Do seasonal, or if you have Python, do seasonal adjustment for the series and check the difference between the non-seasonally adjusted and the seasonally adjusted series. It is an important concept when you start doing analysis from a policy perspective. Okay? You don't want to react to seasonal factors. If inflation during the first quarter goes up and the governor calls you and says inflation has gone up, should I do something? What will you say? What you will say is, let me go home, think about it and come back. Because I want to understand how much of this increase in inflation is because of seasonal factors like TET, how much of this increase is because of other factors. I want to separate out the impact of TET because we should not worry about it. It's a temporary thing. It's a temporary increase in inflation because during TET, consumption does go up. Production goes up. Employment goes up. So I want to react to only that part of the increase in inflation that is not related to seasonal factors. And even within that, I want to react to only things that are not temporary. which are long term. That's why seasonal adjustment is important. So I would like you to fill the blue columns using the formulas that you have here. So start the first cell here. We use this formula. So go ahead. So the simple thing to do is to copy that formula into the first cell. It will look like this. Sorry, I need to go all the way to the top, right? Because this is the first. I want to calculate the growth rate in the second quarter compared to the growth rate in the first quarter. So I have to put it here. I want to calculate the growth rate between these two quarters, non-seasonally adjusted GDP, growth rate quarter on quarter. This is what I should have here. You will notice that in the formula bar, there is a semicolon before the equal to. If you take that out, you will get a number. Okay. Let me reduce the number of decimal points here. If I take that formula now and copy it to the right hand side, it will give me the growth rate of the seasonally adjusted GDP in the second quarter compared to the first quarter. Look at how big the difference is. Non-seasonally adjustment growth rate is 27.5% between quarter 1 and quarter 2. The non-seasonally adjusted is just 0.9%. That's a big difference. And if I want to find out the growth rate for the other quarters, I just take these two formulas and I pull them down all the way, and if I do that, I get numbers for the entire series. Right?
Yeah, we can do.
The moment you do that, you will notice that there is data in your charts here.
Yeah.
Look at how big the variation in real GDP is if you use the non-seasonally adjusted and if you use the seasonally adjusted. Somehow here you see a lot of difference, but that's probably because of COVID. So up till here, look at how big the difference is between the seasonally adjusted series. Right? If you take out the impact of seasonal factors, then the quarterly growth rate should be much smoother. Here. Here. Good. Go back and go a little bit to the right. So here we are comparing quarter on quarter. But what if we compare the first quarter of 2011 to the first quarter of 2010? There is TET here and there is TET here. There is no TET here and there is no TET here. So the growth rate should not be affected by seasonal factors. When you do a year on year, you're taking out seasonality just because you're comparing a similar quarter to a similar quarter. Let's calculate the growth rates year on year. And again, for that, you can copy the formula. And here, You cannot calculate the growth rate for the first 4 quarters. You will be able to start calculate for the first 4 quarters. You'll be able to calculate only starting in the first quarter of 2011. So it should be F15 divided by F11. And you should have a number that looks like this. And since I don't have data for the first 4 quarters, because I don't have data for the previous year, I will start in the first quarter of 2011. There is no difference between the seasonally adjusted and the non-seasonally adjusted number, at least to the first decimal point. So this is what Vietnamese quarterly data looks like for 2010 to 2023. And once I do that, my chart also fills up. Notice that there is not much difference between the seasonally adjusted and non-seasonally adjusted on an annual basis, because we're comparing the first quarter of this year to the first quarter of previous year, the first quarter of next year to the first quarter of this year. But on a quarterly basis, there is quite a big difference in the quarterly growth rates if you use seasonally adjusted versus non-seasonally adjusted. And for policy purposes, since we are making policy pretty much during the course of the year, we have to use high frequency data compared to annual data. In the case of fiscal, it gets a bit more difficult, but in countries where you have quarterly fiscal data, you can make, and actually for Vietnam, we do have some quarterly fiscal data as well. Just have to go find it, collect it. Here. Happy? Happy? Good? Happy? Good? Okay. Let's now see, now that we have quarterly real GDP data, can we estimate potential output using the kind of things that we were talking about before? Remember, we have two methods for, we've discussed two methods for estimating potential output. One is the deterministic trend, and the second one is the HP filter. So let's apply both of those methods to real GDP data for Vietnam. In the next sheet, where it says potential output, we picked up the seasonally adjusted data for Vietnam from our previous sheet, right? Okay. This is the seasonally adjusted data. This is the year-on-year growth rate. Remember, to estimate the deterministic trend, we first need to take the log of real GDP and then estimate a regression. Okay. So, what was the idea of the deterministic trend? The idea in the deterministic trend was that let's say we have real GDP, we need to take the log of the real GDP, step number one. Then we have to run a regression of y is equal to alpha plus beta t plus epsilon t. We need to estimate from here the alpha hat and the beta hat, and our potential output in logs is alpha hat plus beta hat t. Correct? Then we have to anti-log it. So from here we can get a y star, which is t raised to the power y star. Once I have a y and I have a y star, my output gap is this divided by potential output multiplied by 100 is my output gap. This is what we said in the slides. So let's now implement this in our spreadsheet. The first thing that we need to do is to take the log of real GDP, and I can take the log. I have the formula on the top. Here's the log of real GDP. Everybody has that number. I can copy that number down. I now have a series on log of GDP. Okay. Notice that as soon as I put this in, I get two numbers there. Did you see that? Right? So when I don't have numbers here, I don't have anything there. But as soon as I have now that I have a series on log of GDP, the formula in the Excel file is the intercept of the series D11 to D68. Okay. So 13.4 is the estimated value of alpha. What is the estimated value of beta? 0.0148. Correct? I can now use these estimates of alpha hat and beta hat to calculate the log of the potential output. That I just need to use the formula. In the formula, I want to use the intercept everywhere. I want to use the slope parameter in all of these numbers, but I want to change the time period from 1, 2, 3, 4, 5, 6. So that's the correct formula for Excel. And as soon as I take out the apostrophe out, I get a number. And if I copy the formula down, I will have a series which gives me the potential GDP in logs. I can now find the anti-log. Okay. And all I need to do is take this number and raise it to the exponent. Take the exponent and raise it by this number. And it will give me the potential output for that particular quarter. Okay? Clear? Yes. My potential output is different from my real output. Therefore, I should have an output gap. In this case, my potential output is lower than my real GDP. So my output gap will be negative. Output is less than potential output. Numerator is negative. Sorry. The other way around.
Potential.
Output is bigger than potential output. Looks like the first quarter, looks like 10 million. I don't know, who knows. Okay, so once I have that, I can calculate my entire series for potential output. And then, of course, I can calculate my year-on-year growth rate of potential output. I take the first quarter of the next year divided by the first quarter of the previous year, and I start doing that in 2011. Look at how smooth that number is to the third decimal point. Right? It's the same number. It has to be one number. It has to be one number that is related to this number. Because that's the growth rate. Right? Single number. It's a deterministic trend. One number, year on year, every year. Well, my charts are also beginning to fill up. This is my real GDP growth. And this is my trend growth rate at 6.134. Correct? I think I did okay. Did okay? Huh? Okay. Now, once we have the linear trend, we can find out the output gap. So go to the estimated output gap related to the linear trend, and let's fill this column. Here's my output gap, and as we said, one said, it's a positive output gap. Okay, sometimes the output gap is positive, sometimes the output gap is negative. Good. Sure. Okay. Now, once I have the output gap, it should show up in my graph too, right? This is my output gap calculated from the linear, a deterministic estimation of the potential output. graphical representation of my output gap. Once again, quite sensible. This is COVID. Not of this is COVID, probably. But it's interesting that even during COVID, the output gap in Vietnam is positive in some quarters. This is 2021 is COVID, right? The output gap is positive in some cases and negative in some cases. Right? You would think that the output gap is negative, should be in all quarters, because the economy is going through a huge shock. Okay? But this is data that has not adjusted for that very big shock. It's just doing a seasonal adjustment. It has not taken into account this very large shock, global shock, okay. Let's go back and see whether we can calculate the potential output using an HP filter within Excel. And how are we going to do that? We need to use our macro, and we need to use that macro that we have not just on one point, but on the entire series. Because we calculate HP filters not point by point by point. We take the entire time series and we are trying to fit a curve to the entire time series. So what we have to do is to fit a curve to this entire time series. Okay. And to do that, we have to use the macro, and to use the macro, we have to put in something which says HP, the HP filter. And I want to apply the HP filter to the log of the real GDP. I need to select everything from the first observation to the last observation. But there is one more thing I need to do to apply the HP filter. I have to choose a smoothing parameter. Remember that lambda has to be chosen. So I have to tell the macro that I want to use a 1600 lambda because I'm working on quarterly data. The second thing that you have to do, the way you apply the macro is in the instructions, but do the following. So choose the entire column here up till 68. You have to choose not one cell, but you have to choose the entire column from the beginning. And then you have to say is equal to HP. So you want to apply, you want to get the HP filter answer here, and you want to apply the HP filter to D11 to D68. You want to apply to this set of numbers, and as soon as you put that, you see that this is being highlighted. You want to put a comma, and you want to choose if the macro is waiting for you because it wants you to tell it what smoothing parameter you want to use. And the smoothing parameter that you want to use is this number, L6, but you want to use this number again and again. Okay. So in this set of cells, you want to find the HP filter of this series using that zoning parameter. Now you don't do enter, you do control shift enter, I think.
I see.
When you do control shift together and press enter, it calculates the HB filter for that time series using the lambda parameter that you have given. So try and see whether you can get numbers that look like this.
Con biết mảng á. Nhưng mà
Your first number should be 13.414.
mình cũng control shift enter. Can you move to the last row? Can I see the formula of the last row?
You want to see the last row?
Yeah, right. Last
68?
row. Yeah.
68, okay.
Can you zoom in on that so I can see
Oh, enlarge it.
the formula for that? Sao cô chị nó không nhảy á?
See, once you run the macro, the formula here
Nhảy mất.
will tell you that you run a
Mà
filter.
nó không có fit cái này.
So the answer is not, it's in these curly brackets.
Khoan, chị cài cái hàm kia cho.
Ủi cái.
Got it?
So we have to select all the column first and then hide the
You have to select that.
table. So
Nó chạy.
it's just like,
Since it's
stuck. Yeah,
sorry.
yeah, it's okay.
Can you wake it up again?
Yes, yes.
Nó chạy cái bảng. Của chị nó chạy.
Chị biết sao không? Nó bị dính cái này nè.
Đấy là control shift enter kìa.
Yes, xếp nó
You have to
Vậy
choose
hả?
from
Ý là từ
the
từ rồi bỏ lên lại giùm
Lên
chị.
control shift đi, control shift đi, control shift đi. Rồi, control D.
Đi. Ok. Ví dụ vậy nha.
Cái file á.
then control shift.
Phải gì?
Cái file HB của chị á.
Mấy đây chị tải của thầy xuống mà đâu có làm được gì đâu.
Chị cài được rồi đúng không?
Cài rồi. Cài rồi, nãy thầy kiểm tra là cái file đó cài vô đây rồi. Không chỉnh gì phải đâu. Ý là cái mạng của chị nó chạy. Nó moving. Ví dụ mình chị lắp lại á, chị lắp chọn lại á, thì ok. My table moving. Cái tiết cục của
Chị sai rồi, chị đánh máy đúng không?
đánh đâu mà đánh tao copy cái này xuống mà. Ý là tao copy cái này
Đây
nè.
đây chị.
Ý là
Quay nó khác chị một cái. Mà nó có thêm một cái. Đúng rồi.
nè, có nghĩa là chị copy ở trên này xuống. Đó. Xong cái chị bỏ cái phía này đi. Đó. Control shift
Enter là enter.
từ đó là chị á enter thì nó đang vậy nhưng mà control shift enter kia
You don't touch the computer. You tell her what to do. Explain what needs to be done.
chị nó chạy
No touching the computer. You tell her what to do.
Doctor. Her formula look like it's something like it's more along with
move around we want to fix the table but
This is fine.
but the other the last
numbers
one
are not the same.
yeah,
not the
that's
same not the same because the table in here move
Because here, yeah, you have to select this entire thing first. Okay, this is equal to HP.
So,
Not,
and then-
not that one number.
and then control
Now
enter.
put it in.
That You
Okay.
try again.
Because you find not the HP filter for a cell, you find the HP filter for the entire series.
All right. Let me try again.
Because you did one cell, then you copied the formula down. No. You have to select the entire
I see.
cell. Easy. You have to first select is equal to HP D11 to D68, comma $L$6, because this is your smoothing
Yeah.
bracket. Now Control Shift Enter.
I see. Thank you. Trời
Am
ơi.
I happy? Very happy.
Thì ra là vậy. Không biết mãn mà mãn chưa tới.
Quite possible. This is complete shift version.
thấy còn chẳng cái biết của em cũng có xếp anh ta nó không
Nó không control shift enter được. Thôi, không dám đụng vô mát đâu. Không dám chơi với mát đâu, mát chơi với nhau đi.
My computer is control alt. Is it control alt or control shift? For me, it's control shift. Right? In the instructions, it says control shift and then enter. On your computer, the two keys that need to be pressed together, which are the same as control alt, are different, I think. So just both of them together and now hit enter. Your computer has some other keys that you need to but every time you try,
Nhưng mà có điều cái job mà chị có người làm đây vô. Thôi hẹn em kiếp sau, lộn hẹn em kỳ sau.
It's possible that your HP filter is not active. Where is your HP filter on your computer? Where is this finding? Are they in the same folder?
Thì bên bên này nó là văn phòng của mình chán lắm nè, nên là mình có thể được review tốt á, top công ty á, top lợi nhuận.
Probably HP
Nhưng mà tôi
some
nói chuyện nói chung một cách thì không phải là dễ, chỉ có điều là mình cảm thấy mình làm được cái gì thì người ta có một cái lạ.
Chỉ cần những thi sĩ em tấm vậy thôi. Thấy
Không thấy là được á, vậy em phải ôn kỹ cái chương
số 7 á.
ôn kỹ vô sáng vô.
Em không có tìm thử liệu rồi nó không có đánh giá được cái gì kiểu nó
Đúng rồi, cái vấn đề bây giờ là dữ liệu. Mà em tìm cái nó từ hồi có em thấy không có bao nhiêu, ít là không có nhiều cái research. Thì đó cũng là cái điểm mạnh điểm yếu đó.
Với những của mấy nó bị sai rồi.
Bây giờ là mình đi làm lúc đó là
It's still not running.
đầu tiên em sẽ tìm được các cái của nước khác có thể hoặc là em có thể phát triển được các cái market mà mình chưa làm được em liên tiếp liên quan
What can we get lunchtime?
tiếp
And
làm tiếp lúc đó thị trường Việt Nam là nó có những cái bộ
Let me do the
để
following.
tìm cái phần nữa
let me do the file
mình phải bước
with
vô thì
the
mình mới mở được
HP
cái
filter
cơ hội
on
đi vô.
for you or send you an
Đầu tiên
email
là em
with the
phải
file.
tìm hiểu những cái liên quan đến cái tích em muốn hóa.
Come,
Em thấy cái này có
come.
chỗ đó
So the file as it is now,
em chưa rồi nó
we'll have to figure it out
em
later.
muốn nó em khai thác được mấy cái mảng người sau bên đó hơn
Let me send you an email
chị
with the
thấy
file.
chị thấy rất là rộng, nhưng mà bây giờ nó bị khó cái là mình phải làm gì để thì bây giờ làm sao bây giờ chị bảo đi tìm một cái khác em phải có thể mà ổn bắt bây giờ mọi thứ phải đi theo cái mình mong muốn làm thôi. Đúng rồi, bây giờ em chỉ tập trung vào em
File with the HP.
vì nó
Okay, all right. So let's, we're rushing off lunch, but let's complete this little bit here. Now that we have the log of the potential output, and we can clearly find out. So fill in the next two columns. And fill in the year-on-year growth rate.
Chứ không phải là trong hai đó. Nên là mình suy nghĩ muốn cái gì, muốn làm đào sao cái nào nó vận dụng. Ai có thể làm cái gì.
Xong rồi
two columns with the formula that you see on top. And when you're finished, your spreadsheet will basically look like this. Okay? So we have the potential GDP using the HB filter. We can anti-log it to find the level of potential output. Notice that this growth rate now is not the same year on year. It's changing. Right? Because it's not one growth rate for the entire time period. It's a curve that's fitted to the data, and we have an output gap for the two series, and they can give a different answer. Right? Here the output gap is negative, here the output gap is positive. Right? And the size of the two things can also be different. The moment you fill in that last column, you will see that your graph will show you the output gap as you've calculated it from your HB filter. The red bars are your output gap calculated from the HB filter. Your blue bars are the output gap as you've calculated it from your deterministic curve. Okay? Okay? Does everybody have two charts that looks like this? If your charts look like this, you can go for lunch.